Hello one and all, and welcome to the Magical Mystery Show. I'm just kidding. So in this one we're going to take a look at finding the implicit derivative, and then we'll explore it using a picture. So imagine that I'm going to begin here with x² plus y² equals 1. Now first thing you should remember is when we say y in this context, you imagine that the y, for example, is really a function of x. So if I wanted to write this more carefully, I would say x² plus y of x, and this whole quantity then squared equals 1. That's a key step because that's telling us something important, which is specifically that when I differentiate, I'm going to do it term by term. So let's take a look. I'm going to now differentiate x², so that becomes 2x by the power rule. That term that contains the y of x and then squared, that has to be done with the chain rule because it's a y of x, brackets, or parentheses, and the whole quantity is squared. So 2y of x, and then you have to differentiate the inside, which is y of x. Well, we don't know what the function y actually is, so we just indicate that symbolically by writing y prime of x. So that is just a chain rule in action. And the 1, remember, represents essentially the radius of a circle of radius 1. That's not a changing quantity, it's a constant value, which means its derivative has to be 0. Now at this point, most people don't use the y of x as the notation. It's a bit too cumbersome, so keeping this in mind, remember y in this context will basically mean y of x. I'm going to rewrite this 2x plus 2y times y prime equals 0. And now let's get y prime by itself. So I'm going to subtract 2x from both sides. So 2y times y prime equals negative 2x, and then divide through by 2y, divide through by 2y. So y prime equals negative x over y. Let's stop a bit at this expression for the derivative and ask, what information does it contain there? What can we get out of it? Now what I'm going to do is just transition to a picture. So here I am trapped in a circle, so to speak. And remember that our derivative was y prime equals negative x over y. So a question that we can ask, given that the derivative is y prime equals negative x over y, how do you find, for example, the points on the circle where the derivative is undefined or its value is, for example, 0? So let's do the 0 portion first. To find where the derivative is equal to 0, you set it equal to 0. That's what it means. I'm going to write negative x over y, the expression that represents the derivative, set it equal to 0. Okay, multiply both sides by y, that cancels, I have negative x equals 0, divide through by negative 1, so x equals 0. So at the value of x equals 0, the derivative, as you can see, is 0. Let's understand that graphically in a little more depth. So remember that here, this is the origin in this position, and here x is equal to 0. When x has the value 0, to be on the graph, you gotta go up to y equals positive 1 up here. And then, up here, the tangent line would be horizontal. In other words, the derivative would be 0. So let's indicate that by graphing a line that's tangent, just like that, but horizontal. How do I know that it's y equals 1? You can always use the original equation. So what I mean is, for example, we know that the derivative is 0 when x has the value 0 from our calculation. Which means if I plug this into the original equation, I would have the following, in other words. I would have 0 squared plus y squared equals 1. So the 0 goes away and you end up with y squared equals 1. Take square roots. So y would be equal to plus or minus 1. Which means this corresponds to being up here as one value above my head. But then we also have to take care of the negative 1 portion. Which means we have to now slide down through our circular world. Stop right there because here the value of y is negative 1, and then again the derivative is 0. In other words, the tangent line is horizontal. Now that does not look very horizontal. So I need to fix that to the best of my ability. Alright, that's a little bit better. It gets the idea across. It's basically as if I were sitting on that line. Another common piece of information that we might ask for is, for example, where is the derivative undefined? So remember, our derivative was y prime was equal to negative x over y. So for this to be undefined, the value in the denominator has to be equal to 0 because division by 0 is not allowed. So I'm going to take my expression y and set it equal, for example, to 0. Well, that's already solved. There's nothing else to be done there. So at y equals 0, the derivative is undefined. And again, that would be because negative x over 0 is dne. Since we know that y is 0, we have to find the corresponding value of x. So you can do that by, for example, go to x² plus y² equals 1, which is our equation. And I'm resting comfortably here at the low point in the circle. Low energy point there. Let's be serious now. So replace, for example, y with 0, and I would have x² plus 0² equals 1. Solve that for x. So x² equals 1, which means x equals plus or minus 1 once I take square roots. So that means, let's travel through our circular world here, over to here, right here. This is x equals 1. You would indicate here by doing this. That means that the derivative is undefined. In other words, the vertical line is the tangent line there. Let's also scroll over through our world here into this position. And again, here, the value of x is -1. That was one of our solutions. So now I'm going to draw a line this way to indicate that the derivative is undefined at x equals -1. These are some of the common kinds of questions that you ask about this. So let me zoom out here on the picture and put myself at the center of the circular universe. Be serious. Thank you so much for watching. Please leave a like and subscribe. I'll see you in another video.